This message is especially for students who are currently enrolled in Huawei Online Course and are facing difficulties in getting completion mark after watching the lesson videos. Many learners feel confused when they complete a video but still do not see checkmark symbol appear in their course progress. This often leads them to think that they have missed something or system is not working properly. To clear this confusion, here is complete explanation of how Huawei platform tracks your progress and how Mark is actually awarded. Huawei Course requires two things for a lesson to be marked as completed. The first requirement is that you must watch full video without skipping any important part. Even if you skip a few seconds or jump forward in the timeline, the system may not count your video as fully watched. Therefore, it is important to play the video from beginning to end at a normal speed. Close all unnecessary tabs and make sure your internet connection is stable to avoid interruptions. The second requirement, which many students forget, is to read the text that appears below or after the video. Every Huawei lesson contains written content, explanations, or additional information that the system expects you to read. If you only watch the video but do not scroll down to read the text, the checkmark will not appear. Watching alone is not enough. The platform checks whether you have interacted with both the video section and the text section. Once you complete these two steps, 1. Fully watching the video, and 2. Reading the written text, system will update your progress and show checkmark symbol. This indicates that lesson is officially completed. The example video we are sharing is provided to help you understand exactly how the process works and how the checkmark appears when everything is done correctly. We hope that this detailed explanation helps you understand the proper method to complete your Huawei lessons without any confusion. First, we will look at Machines That Think, which introduces the basic concepts of artificial intelligence, AI. In this video, he explains the early ideas of AI, how it works today, and where the concept originally came from. He says,
Welcome to this Seeds for the Future course on artificial intelligence. What we just saw in the cartoon was a car with a level 5 AI system, a very advanced level. Cars like that do not exist yet.
He explains that although such fully autonomous machines are not real today, AI has become common in our everyday lives. For example, some people can adjust the temperature in their homes using only their voice. Online companies like Amazon study your previous purchases and recommend products you might like. At Huawei, AI is widely used in daily operations. The AI used there is not as advanced as the androids seen in science fiction movies like Star Wars, but it is still extremely helpful in running the company efficiently. Mike then says they will watch a short video clip and afterward return to the basics of AI. He asks two important questions. What is AI? Where did this idea come from? Humans have imagined intelligent, self-operating machines for thousands of years. For example, in Greek mythology, there was a giant bronze robot named Talos who protected the island of Crete by throwing huge stones at enemies. In literature, artificial beings who think on their own have been a popular theme for centuries. A famous example is the novel Frankenstein, written over 200 years ago by Mary Shelley. These early ideas show that humans have always dreamed of creating machines that can think, act, and make decisions. In the real world, the development of artificial intelligence advanced alongside improvements in computing power. In the early days, computer scientists debated whether machines could truly think. One of the pioneers was Alan Turing, a mathematical genius who built a machine during World War II that helped decrypt messages encoded by Germany's Enigma system. In 1950, he introduced the famous Turing test, designed to answer the question, can machines think? According to Turing, if a machine could fool a human into believing it was also human through written conversation, then it could be considered capable of thinking. In his time, no machine came close to passing the test. Another major figure in AI history is John McCarthy, an American computer scientist who coined the term artificial intelligence in 1956. In 1958, he created Lisp, a powerful family of programming languages still used today in AI research. Lisp helped pave the way for intelligent machines capable of independent operation. In 1966, McCarthy also created the first chess-playing computer. A third pioneer, Marvin Minsky, also an American computer scientist, made major contributions in the 1970s. One of the pioneers was Alan Turing, a mathematical genius who built a machine during World War II that helped decrypt messages encoded by Germany's Enigma system. In 1950, he introduced the famous Turing test, designed to answer the question, can machines think? According to Turing, if a machine could fool a human into believing it was also human through written conversation, then it could be considered capable of thinking. In his time, no machine came close to passing the test. Another major figure in AI history is John McCarthy, an American computer scientist who coined the term artificial intelligence in 1956. In 1958, he created Lisp, a powerful family of programming languages still used today in AI research. Lisp helped pave the way for intelligent machines capable of independent operation. In 1966, McCarthy also created the first chess-playing computer. A third pioneer, Marvin Minsky, also an American computer scientist, made major contributions in the 1970s. He proposed the Society of Mind theory, which suggests that human intelligence results from the interaction of many simple, non-intelligent components. He famously defined AI as the science of making machines do things that would require intelligence if done by humans. Many people assume that building AI mainly involves software coding, but it actually requires knowledge from at least 7 different academic disciplines. This means people from very different backgrounds must work together, which can make AI development extremely complex. AI uses tools like pattern recognition, statistics, and machine learning. Although some learners are surprised to learn that statistics is essential to AI, experts explain that it is necessary for organizing and interpreting the data used to train AI systems. This leads us to the question, how do machines learn intelligence? A chart in the course explains the relationship between AI, machine learning, and deep learning. Artificial intelligence, AI, is the broadest field. Machine learning, ML, is a subset of AI, focused on designing methods for computers to learn from data. Deep learning, DL, is a newer subset of machine learning, inspired by the structure of the human brain. Deep learning uses artificial neural networks, ANNs, computer systems modelled after biological neurons. In these systems, artificial neurons send signals to one another, similar to how human brain cells communicate. This allows computers to interpret complex data such as images, sounds, and text. To end the lesson, the instructor asks a question. What 4 things are needed to create any AI system.